So in this video, we're going to look at the implementation of the return method, the return function in the list monad. And again, just to write down the monad law. So the monad law that we've looked at is that the bind on some function f prime, function composition with return is equal to bind of return function composition with some function f prime is going to be equal to f prime. Now this is very, very similar to what we had looked at before side effects and before monads, which was the ID function. The ID function is a function that basically takes in an x, some value, some value x of some. It could be of any type, but all it does, it basically gives it back. It just echoes it back. And we looked at f function composition with id is equal to id function composition with f equals to f. Okay, so this property nicely holds, and all we're trying to do right now is looking at the set of functions f prime and g prime that have the type signature that goes from int to a list of integers. Could we find an equivalent to the id method? Okay, is there an equivalent to the id method such that bind of f prime function composition with return is equal to bind of return function composition with f prime is going to be equal to f prime there. Okay, so first thing is, what is the type signature for this return here? Well, we've looked at this in the last video that bind simply upgrades. It simply upgrades the function that you feed into bind here. So bind in this case, in the context of a list monad, is basically a function that takes in some function that goes from an integer to a list of integers and gives you back as an output the upgraded version, such that the input has been upgraded from an integer, from a type integer to a list of integers, right? So that the function composition can actually succeed of doing bind of f prime function composition with g prime. So all of these things we looked at in the last video. So first thing I know from here is that return is basically a function that has a type signature of something in this specific context. In this specific context, goes from an integer to a list of integers. Okay, now what would an implementation for this look like? Now again, if I just scratch the surface a little bit here, and not a really exhaustive proof here, but something just to give an intuition. If f, let's just make some values up here. Let's say f prime takes in as an input some integer, and let's call it integer, takes in as an input some integer 5 there. What's the output of f prime of 5? The output of f prime of 5, we're just going to make some value up. So let's say it gives you back a value that happens to be a list of integers, and let's make that list of integers 1 comma 2. Okay, I'm just making a function up. I'm just making some arbitrary function f prime that happens to obey that type signature. Okay, so if it gives you back a list that contains 1 comma 2, what should the output of this entire piece look like, of this entire piece in blue there? Well, f bind of return function component f prime should give you back as an output. If this entire blue piece takes in as an input some value 5 there, it should give you back as an output again 1 comma 2. And likewise, whatever this piece over here that I have before the equal sign, if it takes in as an input just an integer 5, out should come back a list that contains 1 comma 2, so that this entire monad law holds. Okay, so let's see what happens at this end over here. Well, this f prime, okay, is going to, so what's the function composition of bind return function composition with f prime? Is going to take in as an input some integer. Let's say that integer in this case is going to be 5 as well, because I need to make sure it is in sync with whatever's on my right hand side. If this took in 5, I must feed in 5 again over here. If this takes in 5 as an input, what is f prime going to produce? F prime is going to produce a list that contains 1 comma 2. Now what's who's going to consume this list 1 comma 2? This list 1 comma 2 gets consumed by this purple box, this entire piece over here, purple box. Okay, this piece in purple, which is basically this piece over here, that's the type signature of the piece in purple here, is going to consume that list of 1 comma 2. But what is exactly this piece in purple going to do with that list of 1 comma 2? Well, let's just think for a second that we don't know what it's going to do with this 1 comma 2, but I know that the output of this purple piece must be again that list 1 comma 2, so that it's in sync with the output of this f prime there. Okay, so again, if I look at this implementation here, can I reason out what should be happening in that place there? Sure, I can reason this out. I can see that what's happening is that that's this list 1 comma 2 that gets fed into this purple box. Once it goes into the purple box, what bind does inside that purple box is going to extract the one out from that list, is going to extract the two out from that list. How do I know that? Because that's what bind is doing here. That's the implementation to the bind method. What bind is doing is going to call the map function as part of its implementation, and is going to extract each y's from that ys. What is my ys here? My ys basically is this piece there. But as it extracts each of these ys here, it's going to feed it into this f prime. What is my f prime here? My f prime here in this case is acting as my return method. Because when I say bind of return here, think of this f prime as my return method. So what should return do as it acts on each individual y's that gets extracted from the ys? Well, what it should do is it should make sure that it doesn't change that in any way, so that if return goes from an integer to a list of integer, and when you feed in one such integer out from that list of 1 comma 2, right, it should just give you back another list of integer with that value encoded in that list there, which means that this f prime, which is basically my return in this case, when it takes in that x, it should give you back just a list containing that x. Because only if that happens, then the bind of return with the input of 1 comma 2 is going to give you back as an output a list of 1 comma 2. Only in that scenario it's going to happen. Otherwise, it just wouldn't, you won't have the output of this entire piece in sync with the output of f prime there. Okay, let's just look at things just before the equal sign, if that also holds, if I have this implementation, if this implementation for return present for the list monad. Okay, so now if I think about this again, what does return take in as an input? Well, return in this case takes in as an input whatever's fed on this side of the equation, which is 5 and 5 there. So return takes in as an input 5 there. Okay, what does it do with that 5 there? It just makes it into a list of 5. So in this case, the output of return of 5 is basically a list containing 5. Now, who consumes that list of 5 there? It gets consumed by this pink box over there. Okay, so this pink box over here is going to take in as an input that that list containing 5 there. What does the pink box do with it? Well, the pink box, what it does with it is bind of f prime. What does bind of f prime do with that list that you feed in? This is ys. Ys over here is acting as a list containing 5. Well, what the pink box really does is going to extract each y out from that list of ys, and this y happens to be just 5 there. So when this list of 5 goes inside there, somewhere inside this pink box you're going to get the 5 out from that list there. Okay, so this 5 is basically an integer, and with that integer I'm going to feed it into f prime, because I can see that once I extract that 5 out from the list of y from the ys there, it gets fed into f prime. And what f prime does, well, f prime in this case is basically my function f prime here. What does f prime do with my input 5 there? Well, I'm proposing that f prime, when it takes in 5, is going to give you back a list that contains 1 comma 2. Alright, so what is the output of f prime now? Well, the output of f prime is just going to be a list containing 1 comma 2. Alright, but once I apply map on that, it's going to be a list of 1 comma 2, right? Because map in this case is going to give you back the output of map f prime ys as a list of integers. F prime is nothing but just giving back an output of list of integers. And if I apply concat on that, concat flattens the list out to give you back a list containing just 1 comma 2. So the entire output of this pink box is now going to be 1 comma 2, such that if this, so just so that we are again clear here, what's really happening is that this entire piece in green, took in as an input some 5, and out comes back a list containing 1 comma 2. This entire piece in orange took in as an input some 5, right? It took in as an input some 5, and out came back a list containing 1 comma 2. And likewise, this piece in blue here, or gray, whatever the color is, takes in as an input some 5, and out comes back a list containing 1 comma 2. So what should the implementation return be? Well, the implementation return is going to be x equal to list of x, because that implementation holds here. Only then this entire thing gets completely, all the types basically match up, the values match up, and the property, the monad law holds here. Okay, so we got the return method the return function implemented, we got the bind function implemented for a list monad, and likewise I can figure out what the m should be. So now again, just to get the m here, the last entity of my monad here. So if I have a function that goes from f prime, this function f prime here, I'm just going to rewrite a function again that goes from an int to a list of int, that can also be written as int. Okay, think about this list over is acting as a type constructor, which means that I can now use an alias. I can create an alias m that is equal to that type constructor list constructor, which means that f prime can now be again rewritten finally. Wherever I see the type constructor list type constructor, I'm going to replace that with an m there. So this could be m over there. And again, I'm just trying to generalize this, right? I'm just trying to generalize this so that we can see that this idea of the bind method of upgrading the input so that the function composition holds is true for every monad. So this bind method that was very specific to this list monad, and again it was very specific to these integers here. Okay, because you're just playing with a concrete example, just to give you the intuition, just to give you an understand. Sure, that integer could be anything, right? Doesn't need to be an integer. It could be a character. It could be a string. It could be something, right? So this bind over here, okay, is basically I'm just going to replace wherever I see the type constructor, list type constructor, I'm going to make that into m. Okay, so there you go. Okay, where m is basically some kind of a side effect. In the list monad, it basically happens to be a list. If I'm looking at a maybe monad, that could be some kind of an exception or an error that could be thrown here, or it could even be a state. I have a video on entirely of a state monad. It could be a state there, and but that's the idea. Okay.